Hello guys, I am Kumar K, your favorite DSA mentor when it comes to solving hard unseen DSA problems of the top tech companies, online assessment OAs, and interesting competitive coding contest problems. Guys, I'm observing that these days, what students are doing is that they just keep on solving the standard DSA sheets and standard easy lead code and GFG problems. I'm observing that, and at max they do daily challenge problems of lead code and GFG, which are again easy and mediocre in level. And then guys, the students start facing lots of issues in their online assessment where hard unseen DSA questions are asked. They face problem in CP, they have low ratings, not able to solve CP questions. And in the interviews also, if any DSA question is twisted or changed a little bit, they start facing issue. So how to solve this issue? You have to practice more and more hard and unseen DSA questions where your thinking skills are being applied. If you do that for an extended period of time, then you will be becoming better at that. And if you want to master the hard level DSA OACP in the best way in the country, you can join our program where we give the daily life training, 850-hour course, and one-to-one mentoring with me, and referral support, and many more things. Okay, so today's question is very difficult. Okay, this one is the hardest DP question asked in the lead code contest for this month, I think. Okay, even if we combine the last month, this one is the hardest one. Okay, so guys, if you're only doing standard DP problems and daily challenge problems of DP, you cannot solve this question. If you are a student from, let's say, my course, from session number 50 to session number 80 of dynamic programming, we have 150 videos of dynamic programming in our course. 150 videos of 150 hours. If you go to session number 60 to session number 80, you will find out that many sessions are taken there, which explains and solves many of the 2D DP problems involving the prefix suffix optimization on the top of the DP, LIS mixed with 2D DP, partition DP, subarray DP mixed with 2D DP, and the optimization. If you have done those things, this problem is 85% similar to them. So you can easily solve them if you have done those things. Okay. Now, guys, before we start the session and we head towards the prerequisites, let me congratulate our successful students. Guys, we have had so many selections in the last 2 months, but in this video, let's congratulate the top 4 students. So guys, one of the students, Harini, she worked very hard and trained in the best way possible with us for DSA OECP 1-to-1 mentoring, and she cracked Amazon few days back. Another student, Sukriti, she also this offer was off campus Amazon offer, and Sukriti also cracked off campus offer from Amazon. And then my student Shivam cracked SD intern at Google. Google asks, what level of DSA questions in OA interview. He was my student, he cracked it. Then the student Abhirami, she also cracked off campus offer from Amazon, also became knight on Leetcode. So guys, congratulations to all of them. Now guys, let's head towards the question. Guys, video is going to be long because this is the toughest DP question, and if you're patient and you give me some of your time, you will automatically become strong at half of the DP concepts. Okay, hard unseen DSA and DP concepts which you might be not knowing. Okay, so which you might not be knowing. So please give your time, please give your attention, and put your full focus and attention towards the session. Now let's start. So, guys, the first concept we need to understand to solve this problem is the LIS concept. So, let's start discussing the LIS concept first. Very happy and very lovely I feel while teaching you this question. So, guys, the LIS concept. Longest increasing subsequence. You need to ingrain this concept in your head. You should deeply feel this concept. You should know exactly what happens when you're trying to find the longest increasing subsequence using dynamic programming in an array. If you understand the basic fundamentals of it, don't just memorize it. Try to understand it. Then you will be able to apply the same concept to new questions. Okay. So first, let's try to get into the LIS theory in depth. Okay. So LIS, you are given an array like this, guys: 5, 2, 1, 8, 10, 11, 15. What is the longest increasing subsequence in it? For example, let's take an example where I take some lovely array. Let's say I take this array: 5, 1, 8, 10, and let's say 11 and 15. Now someone is asking you that, hey, please tell me, in this array, which subset is strictly increasing. Subset means choose some elements such that all the elements are in increasing order. So if someone says that, sir, can I choose the first three elements? Is 518 an LIS? No, because 518 is not in ascending order. It should be in ascending, strictly increasing ascending order. Okay. No. So which is the longest increasing sequence? The longest increasing sequence is when you select 5, then you select 8, 10, 11, 15. This is the longest increasing subsequence. Why? Because here you can see 5 less than 8, less than 10, less than 11, less than 15, and the length is also the largest. Length is 5. So hopefully you guys got it. What is the meaning of finding LIS in an array? Okay. Hopefully that concept is clear for you lovely people. Now let's go ahead and feel it deeply via DP. So guys, what you can do is you can just make a simple DP array. This is given to you 2, 1, 5, 3, 8, 10. What is the meaning of DP array? DP array, DP of I should tell us the longest strictly increasing subsequence, longest increasing sequence which ends at index I. So basically the ith element should be forcefully included in the sequence. So guys, what is the meaning of DP of I? DP of I means trying to find the increasing sequence such that the last element of that sequence is index I. Okay. So guys, what would be DP of 1? DP of 1 means, let's say this array is array B. DP1 means B1 should be included for sure. So B1 is what? 2. So 2 will be included for sure. So DP2 is nothing but a single element 2. What is the size of this element? 1. If you only include a single element, then it becomes what? 1 na? Of size 1. So DP of 1 is 1. If this is your array B, DP of 1 is 1. Okay. Now guys, what will be DP of 2? For DP of 2, I have to consider the first two elements of the array. My sequence should compulsorily have this element as the last element. DP of 2 means that B of 2 should be the last element of the increasing sequence. So what is B of 2? B of 2 is 1. So if I put 1 in the end, this is one possible sequence if I only take 1 in the end. And then 2 1 is also a valid sequence. Why? Here also 1 is in the end. First sequence is valid. Is the second sequence valid? No. Why? Because it should be strictly increasing, but 2 less than 1 is not valid. So only you can include a single 1 which is of size 1. So DP2 is 1. DP2 easily becomes a 1. Now let's come to DP3. DP3 means the third element should be forcefully included. Third element should be forcefully included. So what is the third element? Third element is this 5. Forcefully included here. Okay, included. Now before 5 I need to find a number which is smaller than 5. So I can include 1 also. Yes. Can I put any more number after 1? Can I put 2? No, because 2 is not less than 1. So 1 5 is a valid sequence. Another sequence possible is after 5 I can try to put just 2, right? This is also valid. Another sequence is just put a 5 and ignore everyone else. The first sequence is valid, its length is 2. Second sequence is valid, its length is 2. Third sequence is valid, length is 1. Which is the largest length? Largest length is 2. So DP3 is 2. Now guys, quickly you can find out DP4. DP4 means what? Last element should be 3. So you only think now what can be the largest increasing sequence? After 3, either you can include 1 or after 3 you can include 2. So 3 1 or 3 2. Let's say 3 2. So what is the length of 3 2? Length of 3 2 is 2. So DP4 is 2. So DP3 also 2. DP4 also 2. DP5. This is also pretty easy. DP5 means the fifth element should be included. So fifth element is 8. Rather than going with 3, I can go with a 5, right? and then after 5 I'll go with 2. So 2, 5, 8. It is a strictly increasing sequence. So dp5 is 3. That is the best length we can get. Similarly, what will be dp6? Guys, I hope you now got it. dp5 will be 3, dp6 will be 4, and dp7 will be 5. Why dp7 is 5? dp7 means the seventh element 15 should be forcefully included in our largest increasing subsequence. So if 15 is included, the best sequence will be where you pick this, and this. So 2, 5, 8, 10. You could have taken 1, 5, 8, 10, 15 also, does not matter. So the length of this sequence is what? 5. That's why dp of 7 is 5. Okay. So hopefully you understood what we do in dp. Okay. Now let's quickly understand how do we calculate it. Okay. Let's say I am at index I. Okay. I am at index I. My current number is 8. Okay. I am at index I. Let's say I is equal to 5. I want to calculate dp of 5. I want to calculate dp of 5. This means the largest increasing sequence such that the last element is the element at index 5, which is 8. Last guy should be 8. So you know that the last element of the valid sequence is 8. Last element of the valid sequence is 8. Now what will you do? Now, when you are at index I, you are trying to find the largest increasing sequence which ends at I. Last element of sequence is I. Just try to find the second last element of the sequence. If there is a j such that bj less than b of I, then dpi is dpj plus 1. So कहने का मतलब ये है कि अगर तुमको dpi निकालना है, तुमको दिख रहा है dpi पे करंट नंबर का वैल्यू 8 है, लास्ट एलिमेंट ऑफ द सीक्वेंस कौन सा है? 8 है. लास्ट एलिमेंट ऑफ द सीक्वेंस इज व्हाट? 8. What can be the second last element, guys? Second last element can only be an element which is strictly lesser than 8. So let's say I try to fix that 8 is my last element and the second last element is 5. Second last element is 5, which is coming at a index 3, j equal to 3. Okay. So dp5 will be nothing but dp3 plus 1. What is the meaning of this? dp5 equal to dp3 plus 1 means whatever was the best answer till here. What was the best answer till here? The best answer till here was 2 comma 5. Whatever is the best answer till here plus 1. 1 means my current element 8. If I join all both of them, 2, 5, 8 will be the longest increasing subsequence. So hopefully you understood the concept that whenever you are at index I now, you will travel all the guys from index 1 to index I minus 1 and find any guy. Let's say you find some guy whose index is j. It is sure that j will be strictly less than I. Okay. Google Meet, notorious these days. It is sure that j will be less than I because see, you are at index I, you want to calculate dp of I. Dp of I means what? The largest valid sequence ending at index I. The last element of that sequence is index I only. Now you try to search the second last sequence, and the trick is now you try to search the second last element of the sequence. If you are able to search the second last element of the sequence, whole problem is solved of LIS. So I am at index I. I know b of I is the last element of the valid sequence. Second last element of the sequence will always be from index 1 to I minus 1. So I travel from 1 to I minus 1. I try to find any element whose value is strictly lesser than my current element. If that thing is true, then dpi is nothing but that element index dpj plus 1 and the job is done. Problem is solved. So hopefully you understood that. So the thing is that that's what we do here. You can see that you always try to find the second last element of the sequence. If there is a j such that bj is less than bi, then your perfect answer of dp of I is nothing but the best answer till dpj plus 1. 1 means you're including the b of I element. That's it. And guys, there can be many such opportunities, right? dp phi is dp3 plus 1 because the element at index 3 is strictly less than element at index 5. Similarly, there are more possibilities. One possibility is that it can be dp3 plus 1. Another possibility is even this element is less than the ith element 8 na, so this element index is 4, so best answer you get till 4 plus 1. And then this element is less than this also, so one more possibility, dp of 2 plus 1. Then one more possibility, this element is also less than 8, so dp, this element's index is 1, so dp of 1 plus 1. So out of all these possibilities you always take the maximum possibility. Okay, you always try to take the maximum possibility. So I will show you the C++ code, and guys, make sure that this gets ingrained in your brain, because this concept should be very much in depth in your mind, that whenever we are at index I, we will try to search. I know the last element of the valid sequence is I will try to search the second last element, which will be from index 1 till index I minus 1. Let's say I found the second last element index j. I know that element is strictly less than the current element I. Then whatever was the dpj plus 1 is nothing but dp of I. So if you check the code, that's what is happening there. And guys, what will be the final answer? The largest valid sequence can end at any index. It can end at 1, 2, 3, 4, 5, 6, or at n. So final answer will be maximum of dp1, dp2, dp3, dp4 till dp of n. Hopefully now this concept has ingrained in your brain. If you check the C++ code, you can see this novelty happening here. Okay, I equal to 1, I less than n. I am at index I. I will travel from 0 to I minus 1, and I will try to find any element which is less than myself. So this is the ARR of I is the last element of the sequence ending at index I. ARR of j, we are considering it to be the second last sequence, second last element which can be the valid element of our sequence ending at index I. If this is true, then dp of I can be dpj plus 1. Out of all these possibilities, we take maximum. And finally, maximum of dp1 to dpn minus 1 will be the answer. dp0 to dpn minus 1, because here we are using zero based indexing. Okay. So guys, this concept should be very clear for you to solve the hard version of the Leetcode problem. Is that whenever I am at dpi should tell me what? Longest valid sequence. It should always tell me longest valid sequence. Longest valid sequence such that in the last I is coming, but we don't know about the second last. So I will search the second last from index 1 till index I minus 1. I will try to search index j, which is the second last valid element. So if you find the second last element, let's say at index j, so dpi will be nothing but dp of j plus 1. So hopefully you enjoyed it and it was a good fun for you. Okay, hopefully it was very very fun and very very enjoying for you people. Love you all. Now let's move towards the actual lead code question. Then part starts. Let's try to understand the actual question. We have to find the longest sequence which is valid. Any sequence which is valid will always have the decreasing order of their adjacent differences. You can see that you have to pick up the longest valid sequence, which is a valid sequence whose adjacent differences are in descending order. Okay, for example, let's take 6 5 3 4 2 1. Okay, let's take 6 5 3 4 2 1. They are saying that the largest valid sequence is 6 4 2 1. Why? Calculate the adjacent difference, absolute adjacent difference. What is the adjacent difference of 6 and 4? 2. What is the adjacent difference of 4 and 2? 2. What is the adjacent difference of 2 and 1? 2 2 1. Such a simple thing, and this is in descending order, guys. This time it need not be strictly descending. Strictly descending order is not needed. It should just be descending order. It should just be going, either down or equal or either down. So 2 to 1 is in descending order. Okay, equal values you can ignore, no problem. So the adjacent differences should be in the descending order. What is the order of the numbers don't matter. The only the order of their adjacent differences matter. Okay. Now someone can say, sir, why is 63421 not a valid sequence? Why is 63421 not a valid sequence? If this was your answer, then what is the adjacent difference of 6 and 3? 3. What is the adjacent difference of 3 and 4? 1. What is the adjacent difference of 4 and 2? 2. What is the adjacent difference of 2 and 1? 1. Is this in descending order? No. Why? 3 is greater than equal to 1. But is 1 greater than equal to 2? No. Here it fails. That's why 63421 is not valid. The longest valid sequence is 6421. Now guys, how can we solve this question? Obviously the basic concept remains the same. You will always imagine that this is your array. You make a DP array. You are at index I. You are trying to find DP of I. DP of I, you know now, you have to find the second last element of the sequence. DP of I means what? Largest sequence such that the last element of the sequence is I. Second element is unknown. Second last element. So first you try to make this guy the second last element. If this is not working out, try to make this guy the second last element. This is also not working out, try to make this guy as the second last element. I hope that much is clear to you guys after learning so much about LIS pattern, that whenever Kumar ke sir tries to find DPI in this longest sequence pattern questions now, always you assume DPI means longest valid sequence ending at index I is the last element, try to search the second last element. But guys, directly searching the second last element is of no use. That will not solve the problem. We need to do one more extra thing, and that thing is DPI. Though you already know, largest valid sequence ending at index I, the ith element should be included forcefully. This is not enough to solve. We need to increase the state, because in the question, apart from longest sequence, na, they are talking about the adjacent difference also. So what if I make adjacent difference as the state? DPI difference. DPI difference, guys, should tell us the largest sequence ending at index I such that its difference with the second last element is different. DIFF. So guys, now the question becomes very easy. What is the meaning of, now I'm not just declaring DPI, I am declaring DPI difference. Two dimensional dynamic programming. What is the meaning of this? The meaning of this is the best sequence ending at index I, which is valid sequence, last element is I, such that the difference between question second last element and the last element is diff. DPI diff means you are selecting a sequence ending at index I such that absolute difference of question mark minus I is equal to diff. DPI diff means best sequence till index I such that the absolute difference of question mark with I is DIFF. That's it, guys. So now, in this case, guys, what will be DP0? DP0 means you are considering only the zeroth index element. What will be DP00? DP00 means you are considering nothing but making sure that the last element of the sequence ending at index 0 and the second last element should also have the 0 difference. Here there is no second last element possible beyond this, right? Only one element can come. So DP00 will also be 1. DP01 will also be 1. DP02 will also be 1, and so on till the end. Okay. Now DP03 will also be 1, and so on till the end. Okay. Now guys, if someone asks you, hey Kumar ke, yeah, Kumar ke, can you calculate for me the value of DP1 of 2? Guys, what is the meaning of DP1 of 2? DP1 of 2 tells you the longest valid sequence such that the last element is ending at index 1. What is the last element for array B? what is b of 1 2? So the last element should be 2, and its difference with the second last element should be 2. So guys, let's say question mark is the second last element. Can you find a question mark, guys, such that question mark minus 2 absolute difference comes as 2 only? The absolute difference with the second last element of the last element should be 2. Yes, you can select 0 now. Why? If you select 0 comma 2, this is valid. Why? Because the absolute difference of 0 and 2 is coming, 0 and 2 is 2. So absolute difference 2 is getting valid. And dp1 is making sure that you have considered the array till index 1 and the element at index 1 2 is included. So at the place of question mark you can use a 0. So 0 comma 2. So dp1 2 is nothing but 0 comma 2 is a valid sequence. It is satisfying both the conditions. It is making sure that b of 1 is included as the last element. It is also making sure that the difference with the second last element is 2. So maximum length of the sequence is 0 comma 2 2. 2 is the length, right? 0 comma 2 are 2 elements. So dp12 is 2. dp12 is 2. Now guys, someone comes up and asks you, hey Kumar ke, yes sir, can you tell me dp phi of 3? dp phi, not dp phi of 3, dp2 of 3. dp2 of 3 means what? The last element should be b of 2. This is array b, right? Last element should be b of 2 phi. And the difference with the question mark should be 3. Guys, can anyone use their brain and tell me what number if you put at the question mark so that the difference between 5 and the question mark will become 3? You can put a 2 here. So if you replace the question mark with a 2, then yes, this is valid. So if you're trying to find dp2 of 3, you check this difference is 3, right? Yes sir, this difference is 3. So what will be dp2 of 3? dp2 of 3 is dp2 of 3 is nothing but dp1 of 3 or dp1 of 4 or till dp1 of 300. Why 300? Because the adjacent differences can be maximum 300 only. It is given in this lovely question that all the numbers in the array, which is a big hint, can be from 1 to 300. So their adjacent differences can only be from 1 to 300, right? Why am I saying that dp2 of 3 is nothing but dp1 of 3 or dp1 of 4 or till dp1 of 300 plus 1? इसका मतलब क्या है? इसका मतलब dp2 of 3 का मतलब ये क्या है कि element at index number 2 should surely come. Element at index number 2 should surely come. This is b of 2, right? So this condition is getting satisfied. The difference with the second last element should be 3. So if I put 2 as the second last element, the difference is 3. But now 2 can also go ahead, right? 2 can also go ahead, right? Yes, sir. But. Here comes the big deal. The big deal is that can you take 0 with 2? The difference of 0 with 2 will be what? 2. So can you say that dp23 is 0 comma 2 comma 5? No. Why? Difference of 2 comma 5 is 3. Difference of 0 comma 2 is 2. But this is not in descending order. It should be in descending order. First difference should be the largest, less than equal, greater than equal to, like that, right? It is not following this difference. So basically the trick is that dpi difference is nothing but, let's say you are at index I. You travel from 0 to I minus 1 and find the index j. Okay. Let's say I am at index I. I want to calculate something. So I will go from index I minus 1 to index 0. Let's say I find the index j. I come to know that their difference is diff, absolute difference of bj minus bi. So I can easily say that dp of I of diff, I have perfectly found an index whose difference with I is diff. So I can say that dpi diff is nothing but 1 plus dpj of diff. It is common sense, na? You know that the last element of your sequence will be index I, b of I. The second last element will be b of j. You know that this difference is diff. So whatever is the best answer till j plus 1 will be dpi na. So dpi diff is nothing but 1 plus best answer till j. But what should be the second state for j? If the this difference is diff, guys, what should be the difference with the third last element? There will be some third last element, right? Its difference with b of j is, let's say, diff 2. Diff 2 should always be greater than equal to diff. That's why the answer is 1 plus dpj of diff, or 1 plus dpj of diff plus 1. बेसिकली मेरे कहने का मतलब ये है कि अगर लास्ट और सेकंड लास्ट एलिमेंट का डिफरेंस डिफ आ रहा है ना, तो सेकंड लास्ट और थर्ड लास्ट एलिमेंट का डिफरेंस जो भी आ रहा है डिफ टू, दैट शुड ऑलवेज बी ग्रेटर देन इक्वल टू डिफ. तो हाउ विल यू मेक श्योर दैट द डिफरेंस ऑफ द, you know that this is b of I, you know that this is b of j, and here comes the third last element. Okay, with the last and second last, you know that the difference is diff. That's why you have written here dpi diff. Okay, now you want to make sure that now whatever is the best answer till bj plus 1 will be bi, same lis concept. So 1 plus dpj, but I don't know what to write here. What should be diff 2? Diff 2 can be any integer which is greater than equal to diff. So either it can be dpi diff, can be what? It can either be dpj of diff, or it can be dpj, or it can either be the best sequence ending at index j such that the last difference of it was diff, or the best sequence ending at index j such that its difference was diff plus 1, because bigger differences are allowed. Common sense na, if this is diff, it is allowed for this difference to be diff plus 1, right? So how will you denote that diff plus 1 difference? It will be nothing but dpj diff plus 1. So either that difference can be dpj diff plus 1 or dpj diff plus 2 till dpj 300. Okay. So answer will be nothing but 1 plus max of all these values. Okay. So hopefully you guys understood and enjoyed it. You just need to deeply think about what is happening here. Okay. So if you take max of all of them, then the job is done. 1 plus max of all of them. So I can prove it to you via some example also. One, two, three, four. What is DP 3 of 4? DP 3 of 4 means the third element 7 should be included, and the difference of the 7 element with the second last element should be 4. So I can select a 3 here, right? I cannot take any more elements, because if this difference is 4, there is no other element such that this difference will be greater than equal to 4. That's not possible. So 3 7 is the answer. So DP 3 4 is 2. What is dp3 of phi? You know that dp3 of phi means 7 will be there and the difference with the second last element should be phi. So 2 7 minus 2 absolute difference phi. So 2 comma 7, right? 2 comma 7 is nothing but just two elements, so dp3 5 is 2. Now guys, what is dp4 forcefully including the fourth element number 10, dp4 of 3? So basically 10 should be there for sure, and the second last element which you put should have a difference of 3, so you can put a 7. So 10 can make a bonding with 7, so right away you can write that dp43 is nothing but the bonding it makes with the valid second last element, which is nothing but 7, which is nothing but at index 3, so dp3. But guys, here you will write which numbers. It can see the answer will be 1 plus dp3 of any numbers you can write here from 3 to 300. So what will be the answer for dp4 of 3? dp4 of 3 can be 1 plus dp3 of 3 or 1 plus dp3 of 4 or 1 plus dp3 of 5 till you do this till 1 plus dp3 of 100. So guys, do you know the what is this thing invoking? This thing is invoking and making sure that this element's difference with this element difference is what? 3. Now you know that this element difference with this element difference should be greater than or equal to 3, right? So for this much part is nothing but what? Third index, right? So for this much part, if you are able to get the last difference greater than equal to 3, your job is done. That's why you're writing that dp43 will be nothing but 1 plus dp3 of 3. But dp3 of 3 is what? dp3 of 3 is actually 1. Why? Because third element 7. Is it possible to bring a second last element such that the difference with 7 is 3? You can either put a 4 here or some number bigger than 7 here, but there is no 4 available here, so no possible sequence you can make. When you can may not make any sequence, so you can write 1. So dp33 is 1, which is not a good option. But 1 plus dp34, what was dp34? dp34 was, in the end it was 7, and difference of 4 with 7 is 3. Before that it was 3. So dp34 means you are taking the subset 3 comma 7. So 1 plus dp34 means what? 1 plus dp34 means 34 means what? 3 comma 7, and 1 means 10 you are including. So 3 7 10 is valid. Why? Because the difference between 7 and 10 is 3, and the difference between 3 and 7 is 4. So this difference is descending in order. So hopefully you guys understood this trick. I am explaining again and again so you don't feel uncomfortable. Okay. You should always know, my lovely students, that if you are at index I, you travel backwards, you find index j, you know that absolute difference, you calculate the absolute difference of bi minus bj. Let's say this difference, when you calculate, it's coming as diff. So you can immediately say that dpi of diff, best answer till index I, such that the last adjacent difference with the second last element is diff, is nothing but the best answer till index j, such that its adjacent element with the previous element was diff. Either this can be the answer, or the best answer such that till j, such that its difference with the previous element was diff plus 1. Its difference with the previous element was diff plus 1. Why? Because diff plus 1 will become greater than equal to diff, and it will maintain the descending order of adjacent differences. Or you can say the best answer is, I forgot to write 1 plus, always remember 1 plus dp of j comma diff plus 2. The best answer till j such that the Its difference with the previous guy is diff plus 2. If it's diff plus 2, this difference is greater than equal to diff, maintaining the descending order of adjacent differences. So among all those differences, we take the maximum one, and that's how the problem gets solved. The time complexity will be n square into k. I can show you the code also. Java Python implementations will be uploaded shortly, guys. It gives TLE, but still it makes the concepts clear. So you can see, guys, you're going from I1 to N. Whenever you're at I, go from 0 to I minus 1, find a J. If the difference of the number is nums I minus nums J, so DPI difference is nothing but what? DPJK plus 1, where K is going from difference till less than equal to 300. You know, na, diff plus 1, diff plus 2, diff plus 3 till 300. So we are going from diff and we are increasing the diff. And you can see n square for the first two loops and k for the third loop. So it gets solved like that. Now we will go towards the optimization. So now, lovely people, we go towards the brilliant optimization. Everything, the last part of this video, we start with the name of God, Ram Ram. If you are still with me, it means you really have that fire in you to learn and grow and to become the best of the best. May the power of God always be with you. So guys, in our previous question, what are we doing? Is that we are using DPI diff, right? But guys, how large can this be? Have you imagined? The difference of the numbers can be from 1 to 300. So this state can, iterate from 1 to 300. And DPI I can be from 1 to n, and n is as large as 10 raised to 4, guys. So, it's making things big. To optimize, what we can do is, what are you currently doing? You are traveling from index 1 to index I, right? Till index n, right? And trying to calculate dp of I comma diff, right? So I am saying don't calculate dp I diff. Calculate dp of y of diff. Now you will be saying, sir, what is y? Rather than iterating, earlier you were iterating on the index. You were iterating on the index. You were going from 0 to n minus 1 or 1 to n. Rather than going to iterating to the index, now iterate the number. The numbers. Whatever is the number here, na, the DP value should directly tell you the answer for that number. That will make the things easy. For example, earlier you used to call it as dp3 of 7. Dp3 of 7 means what? This is the third element should be there included, and the difference with the second last element should be 7. So this is also included. So 8 comma 1 2 is the answer. But now you will not call it dp37. Now you will call it as the 7 will remain the same, but instead of 3, na, call it 1, dp1 of 7. dp1 of 7 should tell you the best answer to the question, the largest sequence which ends at number 1. बेसिकली मैं ये कह रहा हूं कि इंडेक्स की जगह वो नंबर को ही अपने स्टेट में घुसा दो, समझे? डोंट से dpi, instead use dp of b of I. That number should be the value of the state. Both are the same thing, but the numbers are only from 1 to 300, na. The Now this second state is for difference will go from 1 to 300, 0 to 300, and the numbers will also go from 1 to 300. So this is making things smaller earlier, but then if you use I, it goes from 1 to n. N can be as long as 10, as large as 10 raised to 4. So rather than iterating the index, iterate the number, and the job is done. Such a nice, interesting thing. So I have shown it here also. We can see that the number of, guys, this document and all the codes are available in the description. Please check it out. Love you all. Make sure you like, subscribe, like my content, love my content. There are many extra sessions and help we do. Please check in the description. You will find it out, everything. We can see that the number of elements in the array can only range from 1 to 300. So rather than using dpi diff, which tells us the best answer till index I of the array, we use dp number of diff, which would tell us the best answer ending at some number mentioned. Just focus on the number rather than the index. This is good because now dp values will go from dp1 to dp300 only. not dp1 to dpn, as n is much bigger than 300 in general. You are at index I. So guys, now how to solve the question? You are at index I. You know that this value is at this array is bi. Let's say y is equal to bi. How will you calculate dpy of diff? This is nothing but same as dpi of diff actually, but it makes the dp look smaller. Dpy of diff means what? The last element should be y. Obviously, sir, y is the last element we can see. And the difference with the second last element of the sequence should be difference. So guys, what is the possibility of the second last element? There are only two possibilities. Either this number can be, second last number can be y plus diff, or the second last number can be y minus diff. There are only two possibilities. Either the second last number can be y plus diff or y minus diff. So if the second last number which we are including in the sequence is y minus diff, so the answer will be dp of this number minus diff. Why? Because this number minus diff will always have the, will make sure that the difference between difference between y and y minus diff will always be diff only. So dp of y diff is nothing but dp of y minus diff, such that its differences were greater than equal to diff, so that the descending order of differences is mentioned. 1 plus dp of y minus diff, and this thing greater than equal to diff, this thing you know how it operates. Or the second last element can be what? Y plus diff, and the second state should always be greater than equal to diff. अगर लास्ट एलिमेंट y है तो सेकंड लास्ट एलिमेंट या तो y प्लस डिफ होगा या तो y माइनस डिफ होगा, तो वही तो लिखा है. सेकंड जो बेस्ट आंसर क्या होगा? करंट एलिमेंट y, जिसके लिए 1 लिखा है, प्लस द बेस्ट आंसर टिल द सेकंड लास्ट गाय, राइट? द सेकंड लास्ट गाय कैन बी y माइनस डिफ. If it is y minus diff, the answer is dp y minus diff greater than equal to diff plus 1. Or the second last, if the second last element is y plus diff, then dp y plus diff greater than equal to diff. Okay. And the same thing has been written here, guys. Okay. dpy diff longest valid sequence such that the last number is y and the second last number is either y minus diff or y plus diff. So dpy diff is nothing but 1 plus either it's dpy plus k diff or dpy plus k diff plus 1 or dpy plus k diff plus 2 or till dpy plus k 300. Similarly, if you are taking y minus k, then this. Whatever is the maximum of both of them, na, that should be your answer. You can check the C++ implementation. Java Python will be uploaded soon. Same thing what I told you just now has been done here. See, such hard questions can be made easy if you break your thinking limits and come with Kumar ke sir. So guys, what is happening you can see. Okay, you can just enjoy the show here. You are going from 0 to n minus 1. Your current element is d, nums of I, d. Okay, you want to calculate dpd of 0 till dpd of 300. For dpd 0, you can do this trick, you can check it out as a homework. For dp 1 to 300, what will you do? Either the second last number can be d minus j. So if the d minus j has occurred before, dpdj is nothing but dpz k plus 1, and this k will go from j till 300. Similarly, the previous element can be d plus j, right? So instead of z, use w again from k to 300, and the guys, the problem is solved. This time one loop you are using for traveling, O of n of k, n into k square is the solution. The time complexity this time is n into k. Very, very nice problem. Now, last optimization which you can do is, guys, can you see one thing you can optimize here? You always have to calculate this thing, right? You always need to calculate. Guys, can you see that dpy plus k remains constant, but they are asking you here the sum of elements from diff till 300. If you can find, the summation of dpy plus k diff plus dp y plus k. If you can find the maximum of all these previous values, maximum of dp yk diff d, see the first state remains the same, only the second value is changing. If you can do this in O of one time, if you can do this in O of one time, then guys inner loop will be eliminated. Inner loop will be eliminated. So let's say you are somewhere, okay, you are somewhere, and someone asks you, hey bro, yeah, tell me the maximum value of some array. I want to know that for an array v, let's say you have an array v, okay, this is the index diff, this is the index diff plus 1 till you have the array of v of size 300. If someone is telling you, tell me the maximum of v of diff comma v of diff plus 1 till v of 300, this is nothing but the maximum of the suffix now. You can pre-compute this answer in a suffix array, right? When you are at this element, you can say that s of 300 is nothing but v of 300. When you are at 299, you can say that s of 299 is nothing but maximum of v of 299 comma s of 300. Like this you can come here, and finally the maximum of v of diff plus 1 diff plus 2 till 100 will be answered in O of 1 because it will be stored in s of diff. So you can see how the suffix sum prefix sum method can be used here. Similarly, when it is made in 2D, you can see the first state is constant, so you don't need to worry about that. From here, you need to know the maximum of the values from diff till 300, and same goes for here, diff till 300. You can use the 2D suffix optimization, and you can enjoy. If you know the maximum values in over one time, the job is done. Such a nice, great thing. You can see a suffix s d array is used, okay, s array is used, and the inner loop is now removed. You just write dpdj is nothing but sjz plus 1, done 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 done. Hopefully you enjoyed the problem. Loved it, I loved it, I loved it explaining.